Can you see a slide?
Not,
You can see?
not yet.
Okay, I think it takes a while. So let's take some time.
No, not yet. Okay.
You can see it now. Okay, so there's a delay. It's a delay. Wow. Okay. So what can you see? Can you read what you can see?
I can see it now.
All right.
Yeah. Data management intro to database.
Okay. So I'll just start. Let me talk about this. This is our topic for today. This is our last but one topic. After this, we are going to look at, I think, one more topic. Then we'll do a tutorial. Then this is the end of the semester. Is that okay? GIS is like that. It's like I have so much to talk about in GIS. Meanwhile, I think it's only 2 credit hours for you. It seems I bother you too much, construction students, with my GIS. But it's very important. This is one of the IT courses that you are taking. You have to know that GIS is IT, information technology. And so no wonder we want to talk about databases. If you can hear me, Prince, can you tell me what you know about databases? Have you heard of the word before?
Yes, sir.
You heard of it before?
Hello.
Yeah, Prince, have you heard of the word database before?
Hello.
Hi, can you hear me?
Yes, sir.
Okay. What do you know about databases?
Yes, sir, I can hear you.
What do you know about databases, Prince?
So it's a collection of data. Let's say, for instance, a bank has customers, and all these customers' information or data about their customers are being stored into a one unit, a component that makes it easier to access anytime
Okay.
they want the data for.
Perfect. So I don't need to do this lecture. I think you
To
understand.
carry out, yes, sir.
Yeah, it's exactly what you've talked about. Data, we are in the information age, so everything is about data. It's okay. And databases are organized collection of data. In other words, you can have data, but it may not be organized. When you are not organized, it's not easy to find things. Are you okay? So if you're in a house and you can't find your socks, normally it's because your whole house is disorganized. Everything is all over the place. All right. So we actually organize data to help us to search. So when you look at the national database, Ghana has been trying, and Vice President Baumia has been talking about it, that we are going paperless, In fact, all he's talking about is that we are going database. That's what he's saying. And so any question on database management, with your what you just said, you should be able to answer it. Is that okay? At the end of the day, databases are used in so many places, not only in GIS. In fact, GIS itself is a whole database containing spatial objects. Are you okay? So your buildings, so let's talk about lands commission, for example. All the buildings, all the lands in Ghana should be kept in a certain database. Are you okay? That's why we talk about databases in GIS. Otherwise, it's of no use to actually talk about databases. Data is organized to model relevant aspects of reality. And so what is reality? Reality is like what we see in the real world. What is going on around us in our world? People are traveling. We're talking about going to library to borrow a book. These are things that people do. People go to a library to borrow books. People go to school to learn. People mine. People farm. There are a lot of things that happen in our world today, and more. There's more. I can keep on and on and on and on and on. People go to hospitals to get healthcare. So all that we can model information and data, excuse me, concerning the real world. Okay, making tax payments. A lot of people don't pay their tax. Why? Because we don't have any organized data about who is supposed to pay it and whether they've paid it and whether they're defaulting. So it's one of the reasons why as a country we don't have a database. Are you okay? So databases are like, I don't know, it's like a lifeline to your development as a country. I don't want to, I'm sounding like a politician now. Is that okay? Uh, Types of databases. In fact, we have so many types of databases, and the reason why we having different types, initially people didn't even realize the need for a database. Are you okay? Initially, people were not recognized that databases were important. So they were actually keeping data anyhow. Databases were kept what we call flat files. So data is kept straight up in one book. You open it up and then you write about, say, Prince, his name, his age. You move from left all the way to the right. You go and go and go and go. And then when it's finished, you open another page. You see, this was done on paper. In fact, the first database was done in a book. Okay? And today, even in some churches, you see that when they go for meetings, it's a huge book. Okay, that they use. So they started with keeping data in what we call the flat file database. Then there was a lot of problems with it. For example, if I wanted to delete something, I had a problem. If I wanted to insert a new record for Jojo, if you look at this example table here, you realize that if Jojo decides to maybe change something, then we have to create another row and repeat the name Jojo, making the database very bulky or the data very big. So it was taking a lot of space and everything. So to avoid that, then people started coming up with what? Different models. So we have what we call the hierarchical database. In fact, I'm not going to go into details and all that. It means that data was organized with the idea of a hierarchy, parent-child relationship. So if I keep data on your house, then I have to make sure that it links up with your district or your town, something like that. Network databases, they're all following network principles. And then the one that we are using today, hinges around relational database model and object database model, where we look at the object-oriented principles. So objects have properties and methods. Are you okay? An object like, every object that you have can have a certain property. So that concept. So object relational is a hybrid between the relational and the object database model. Are you okay? So this is how people have tried to organize data by first building the model, the idea. A model is just a concept, or it's at a conceptual level, the way you are thinking about it. And then later you can talk about the storage. Prince, I'm not going to take you deeper than I need to, because I probably know you've taken a course in database or maybe in IT before. Are you all right? But the basic that you need, I want you to understand. The idea of the lecture is for you to understand. All right. So this is all there is to the models, but I'm not going to go any further than this. Are you okay? I'm just going to talk a little more about the relational database and then some basic concepts in database that you need to know. Are you okay? All right. So the relational databases really allowed us. He's dropped off. All right. So pause share. Okay. Okay, Prince, are you back? If you are back, let me hear you. Say hi. If you are back.
Yeah, I'm back.
You're back. Okay, that's good. All right. Right. So please, you can ask questions as we go because we have the mic. Are you okay? So if you want to say something, you raise up your hand. I don't know if you can see that there's a button to raise up your hand. I don't know.
So please, you need to. So yeah, you need to go back, sir.
I need to go back. Okay.
With
So
the types of databases.
types of databases. Okay.
Because Yeah, the microphone wasn't. The audibility was down. So
Was down. Okay. So I was saying that the very first database that was, not the first database, the database model, the first database model that was created, the type that was created was called a flat file. Naturally, data was kept in rows, long rows from one end to the other. Are you okay? So left to right, Kofi's data will be kept. The team that Kofi is in, his age, his father's name, his uncle's name, his job, everything. Are you okay? All right. Prince, if the audio is not good or there's a problem, try and type in so that I'll know. Yeah. And if you can hear me too, then hey, you can keep quiet and then we can go on. All right. So the flat file database is data kept in the tabular form, like as in Excel. Are you okay? Excel is a typical flat file database. And there are other database types that came up. The hierarchical database actually kept data in the form of, let me just say, the idea of a parent and a child. Are you okay? But like I'm saying, I won't ask you this in exam, but I want you to know that people came up with also the network database. But when they realized that they were not working very well, right? So it's important for you to know that flat file databases were there. If you look at this Excel sheet that I'm showing you, that's a typical flat file database. Are you okay? Can you see it? Yeah, it's coming up soon. You see it. So data is kept straight up in these records. So this is what we call flat file. But the problem with it is that we have repetition problems. You have to always repeat, okay? You have to always repeat data. If I want to store data about you, Prince, yeah? If I want to change your, what can I change about you? Maybe you've changed schools and I want to change it in the database, in the national database. Then I'll have to repeat your name. I have to write Prince and then Prince again. So that's a problem. That means I have to call Prince twice.
Yeah.
So that is the problem. So you were in Harvard University. Someone is worrying you with a call or something, yeah, and you want to go to Princeton. So now I have to keep the Prince twice, and that's a problem. And then when I want to delete you, I have to find all occurrences of Prince and delete it. So that was a problem, basic problem, flat file database. And today, people are still using it, something like this. Like I was saying, even in churches, people actually use, groups in churches are making use of flat file. They are not even aware. Are you okay? They're not even aware that that's what they are doing. So flat file databases were not working. Hierarchical too had its own disadvantages. But what is involved now is, or what is really working is a relational and then the object relational. Are you okay? Relational and object relational, they are just talking about creating relationships between what we call entities. And the entity is just the objects, are you okay, of interest. Let's say we talk all a phenomenon. Let's look at students. So student can be what? An entity. And a student can have attributes, characteristics. Students have student index number. Students have courses that they do. They belong to certain departments. Are you okay? So I'm keeping data on students. I hope you get this one. Please let me know if you follow this one.
Yes, sir.
Yes. So data in the relational database, data is kept in tables, and the tables represent what entities. We will talk more about it. In the objects database, then we are applying certain principles called the object-oriented principles. Are you okay?
Yes, sir.
So the flat file database didn't work. It wasn't good. It had disadvantages, but the relational databases made use of keys and indexes. That's why we have the SNIT number. We have student index number. You see, every student knows that there's something called index number, but they don't know why it came about. It's because of the idea of being able to uniquely identify. Now, but because we have indexes too, we are able to search easily. Are you okay? And also, tables are broken down into smaller tables. Are you okay? So that we can now join them again. That is the whole idea. Because if in the flat file database, data is kept in a single row, then we need to find a way to what? Join them again if you are breaking them up. Because if you don't have a straight up one big table, then what else do you have? Are you okay? All right. So here you go. For search queries, we needed indexes. Are you okay? For search queries, we needed indexes. Then to make sure that we have indexes. Are you okay? So if you look at the Excel sheet that I'm showing you, then obviously this is a typical index. If it's an index, there shouldn't be a repetition. The number should be unique. As you can see over here, we shouldn't see one again somewhere here. So that makes this not an index. Whatever it is that we are calling it, it's not an index. But in an index system, your index number should not be, and you see the danger with having your index number being repeated is that in a database is that we will have two princes, so we don't know which one of them is doing well and which one is not doing well. Are you okay? All right.
Yes, sir.
Any question, Prince? Or you are following?
Yes, sir.
Okay, you are following. All right. So let's move on. So databases are really like tables. You think about it as tables with predefined types. Are you okay? Tables. But in the tables, we have columns in the table. And in those columns, we have what? A certain type associated with it. Are you okay? All right. So if I take you back to our Excel, then you can see that in the Excel, we have this column here. We can define a certain what? Type. We can decide that in this column, we want to keep numbers. Okay. We want to keep currency. We want to keep time. We want to keep percentages. These are actually types. Are you okay? So if I press date, then you can see that it's forcing everything that you put in here to be what? A date. So 6 is a date. 6 is 6 January 1900. I don't know if you were born by then, Prince. No, I don't think anybody was born at that time. By that time, he's alive. You know, so that is data type for you. Can decide that in this field, we want to keep tests only. So we put tests. So if I try to put in a number like 0.9, it's not really a number. Are you okay? See it to be a number, but it's not a number. Okay, now let me try some.
So if I could hear you clearly,
Yes.
you said databases are in a form of columns and
Yes. Yes.
rows, are tables, but in the form of columns and rows.
Yes.
Okay.
Exactly. So these are the columns. If you can see my Excel sheet right now, I'm clicking on columns.
Yes, sir.
Yes. And then these are rows. So the intersection of the rows and columns define a value. So this value here is actually the yellow highlighted cell is actually what? An intersection of a column and a row. Okay, but in databases, we are not interested in columns and rows. We are interested in the column. And the column is actually, we are also interested in the rows anyway, because the rows are actually records. Are you okay? The rows are actually what? The records, what people call records. When you go to hospital, they talk about your records. They are really talking about a role in a database, in a modern system. In an old-fashioned system, we can't talk about that. Are you okay? We can only talk about the record, the record, the record. But when they pick your record, what it means is that they're picking a single row like this one. So Prince, Harvard, your date of birth is here. Are you getting that? Etc. So that is the idea behind the database and what it is. And then the types, I've just explained to you what the types are. So we can have double, integer, date, text. Okay, so depending on the system you are using, sometimes Oracle is a company, they make database systems. They can decide that, okay, we want to call what you are calling integer, we want to call it something else. We want to call it whole number. There's nothing you can do but to follow it because it's a software company and they do what they want to do. They are selling. If you like it, buy it. So these values can change, but we all know in maths that an integer is a whole number, positive and negative whole numbers. Are you okay? Now, what we're calling double here is what our maths teacher taught us in primary school as real numbers. Are you okay? So real numbers are really going to be called double. And then text is like test. You say textbook, it means A, B, C, D. Everything you are seeing on this page is test. Okay? Everything you are seeing on this page is test. Numbers, alphabets, symbols, all that we want to call that word test. So there we go. So we want to actually understand databases very well. Then we need to study it properly. You can even go and take a course. After what I've taught you, you can even still go and take a course in it. And because database, those who design databases, they earn a lot of money. Is that okay? I don't think we are really following money like that, are we? Yeah, money is not really the main thing. Okay? Money is not the main thing. All right. So let's go back to our page. All right. I want to talk about what we call index.
Text Ghana.
Yes. Are you there? Are you good? Are you there? Are you good? Prince, are you there? Prince, are you there? And are you good? Can I hear from you, Prince? Prince, can I hear your voice? Are you there? Hello? It's gone. Yeah, I knew it. Oh, shit. Surprisingly, ACC pending class here. Is it back on screen? I think it's back. Okay. Prince, you back. Hello. Where did you drop off? So that I can carry on from there.
So I went off.
Yeah, so which one did you miss?
You had types of
Data type.
types of data types.
Not types of data. Once you say types of data, it's a totally different thing. Okay.
Okay.
Yes. So in fact, I was talking about data types. In computers and in IT, data types are a whole topic. Is that okay?
Yes, sir.
In fact, data types brings you to data structures and everything. So please, once you swap it, you are in trouble. You are talking about something else. Oh, my neighbor is making noise this morning. Paul, can you hear them?
Yes.
Oh, Papa, we are this morning or 4 morning. I may have a lecture. I feel now grabber. Anyway, that boy is a liar. Okay, let's finish off quickly. Okay, we have just 30 minutes. How many minutes have we spent on this one? Okay, Prince, are you there? Can you hear me?
Yes, yes, I'm there.
Okay, great. We are talking about primary and foreign keys. Is that okay? That's our next topic. Primary and foreign keys. Now, the primary key of a relational table uniquely identifies each record in the table. I think I've already talked about it as the index. Are you okay? Your index number is a typical example of what we call the primary key. It's a column, okay? The column. And the column uniquely identifies the records. So when we say candidate number 1, we know that we are talking about Prince in Harvard. And then we talk about candidate number 2, we know we are talking about Joshua in Princeton. Are you okay? So take note of that. So candidate number 1 is this guy here. All right, let me change the format and see if I get my 1, 2, 3. So you can see that candidate number 1. So this becomes what we call the primary key. Excuse me. So it uniquely identifies the person you are talking about. So someone is given a bank account number. Those 2 people should have that bank account number. So that is the so-called primary key. Excuse me. Primary key.
So someone is given a what? Excuse me.
Yes, please. Yes.
Yes, primary key.
Yes. You asking a question?
So no, it was going off. I
Oh,
didn't
okay.
hear.
Okay. Primary key. We are talking about primary and foreign keys. Okay. All right. I've turned off the video. Maybe the audio will be better now, right? Is it better? Is the audio better?
Yes, I can hear you.
Okay. So the primary, I want you to understand primary and foreign keys. Okay. So the primary key it's like having a table and having one column in the table that tells you who you are talking about. Because don't forget that you're not the only person called Prince, right? You're not, in fact, you're not the only person called Prince Kali. Or are you okay? There could be another person, it's possible, called Prince Owusu. Like 2 people called Isaac Owusu. You know, people can have the same name. Is that okay? And so here we are, primary and foreign key. But the thing about primary and foreign key is that when we have a 2 tables, okay, which is what we do in relational databases, we split the table into 2 and then we join it. We go through a process called normalization and then we split the tables. Okay, the bigger table is split into 2 or more. So what we do is that Praise. So the primary key becomes a foreign key in another table. That's the point I'm making. Is that okay? The primary key becomes a foreign key in another table. But in that other table, it also has its own primary key. Okay. So I hope you get it, but let's see if I can give you more examples. So we can actually have a normal attribute, okay, social security number as an example. All right, or we can even combine columns, different columns. and have a primary key. Are you okay? Right, so like I said, the foreign key is a field in the relational table that matches the primary key for another table. Okay, all right, so when you take an example, customer table, I think I'll give you, we get to that point. You understand? I'll finish the lecture soon because we've been able to even do this. So let's look at customer as an example. Are you okay? We want to keep a database on our customers. Okay. So straight up, when you look here, the customer has an ID, the first name of the customer, the last name, the email address, and his telephone. Then the customer places an order. Maybe you are selling pizza. Okay, so the products, we are selling fridges. So we are game, game is a company, a shop, are you okay? A retail shop or something that sells stuff. So they want to keep the details of their customer, which customers don't normally give out their details. But if it happens that they have, then we can build a database so that I can reach out to them. Are you okay? Right. So I remember that I bought something from a certain shop in the West Hill Malls, and they kept on sending me, text messages. That is what they do. They build a database from the data you're giving them. So over here, we split the data. We're not having one straight row concerning customer ID 0 and then his first name, everything on one row. We have broken it down into two tables and we are going to join them. This is what we call the relational database model. The relational database model. All right. So here, John is customer ID 0. If you want to know the orders that he's made, we come into this table, which is called the order table. So this is the customer table, this is the order table, and there's a join between the two. That's what we do in the relational database. Now you realize that a customer ID now is unique in the customer table, 0, 1, 2, 3. But then there's this order ID, which is a primary. It's primary here, but it's foreign here. So customer ID is primary key here, but it's foreign key in this other one. Are you okay? All right. So that's primary key, customer ID, but it counts foreign key in this one. And that's the product we are ordering. Okay. So that is I want you to let me know if you are getting the idea of primary and foreign key. Let me hear you. Let me hear you. Are you getting it, Kakra?
Okay. So with the first table,
Yes.
the customer ID column. So can you?
So
Hello.
the customer ID column is trying to keep our customers unique. You understand the word unique, right? If something
Yes,
is
sir.
unique, you can't find another one. So
It's distinct from others.
yeah, exactly. So the customer ID here will not be repeated. When we say customer ID 0, we all know that we are talking about the very rich guy called John Smith. And John Smith is coming to shop, and he came and he bought a Samsung, the latest version. Are you okay? But in our database, we don't keep it straight on. In the relational database model, we don't keep a straight record of him. We keep two tables. And in those two tables, there are records. But then one column is repeated in the other table called the order table, which means that the order that the customer is placing, we need to know who is making the order. We need to know the order unique number for the order. So order number 1 is the one that caused the problem, or order number 1 is the one that the customer is returning. Are you okay? That is why they say when you actually buy something, they say bring your receipt, because they keep a certain unique number on it that they can use to refer to the actual object that you are talking about, without which they can't help you. Are you okay? Yeah. So this is the idea of a database for a retail shop, for example. But really, this is just for classroom. Let me tell you, it can get bigger than this. You can have more tables. You can have more interesting columns. Yeah, you can have more interesting columns in there. Are we good, Kakra?
Yes.
Okay. So if I ask you, go ahead.
So in a second table,
we will link
the
this to this.
customer ID. Yes. So the customer ID column becomes a foreign key.
Yes. It becomes a foreign key. Okay. So this customer ID here is the same thing here, but it's only making a reference to this one.
Okay.
Yeah. It's only making a reference to this one. So it's like as if link this to that. This is all we are saying. What we want to avoid is that when he makes more orders, you realize that we have a second order, isn't it? Yeah. If he makes more order, we have order number 2. Then the customer ID is the same guy who is making the order.
The same as 0, yes.
And then he's not buying Samsung, he's buying laptop, HP. So we are designing, are you okay? Or let me just say that we are just trying to understand how the database at ShopRite or Game works. So he just bought a laptop. Now, if we are not breaking the table into 2, what will happen? Can you tell me? We'll repeat his name again, isn't it?
Yeah.
Repeat his email and everything again. And that's what we are trying to avoid. It's one of the basic things we want to avoid. That repetition. Are you okay? The audio is bad, eh? Is it still bad?
Yes, sir. Yes, sir.
Oh, why is the audio bad like that? Does it get any better at all?
It's not really clear. It gets clearer at a point.
Then it goes off again. Okay.
Yeah.
I think it's all because of people are streaming and watching Netflix and all those things, isn't it? Anyway. Go on. Okay, let's talk about how do I even exit this one? Let me see.
Yes, sir. Please, before you go on with the hierarchical database.
Yes, model.
So is it a way of storing data, let's say in an organizational structure or in a family roll call?
Something like that.
Okay.
Yeah, like family kind of parent-child thing, but it's outmoded, so there's no need to. You only need to know that it used to work that way. But if anybody studies it now, in fact, the thing about even relational database model is that, and also it's almost fading. You heard about cryptocurrency and what was that? The principle behind cryptocurrency.
So it was what was it called? They call it electronic currency.
Yeah.
That was you could obtain money electronically and purchase anything or make a transaction with it.
Yes. It was a secured way of actually keeping data and then sharing it. It's actually an alternative to database. Yeah, building. It's a kind of the latest model in terms of databases, but it's not being taught. It's being taught, but it's not being. In fact, some companies are even using it. What it means is that relational databases are more even becoming like a little obsolete. Can you imagine that? So things change. Things change. The thing about databases is that the database needs to sit somewhere and then someone needs to modify it. And if the person, you know how you can go and do an ATM transaction, and then when you do the ATM transaction, then the money doesn't come out. but then the bank records that.
Yes.
So some of these things were not going to be possible with that technology behind cryptocurrency. Are you okay? And so yeah, cryptocurrencies were really like the new way to go. Cryptos technology behind cryptocurrency. Yeah. Blockchain. That's a word I really wanted. Blockchain. Blockchain is like it's almost like the new thing. Blockchain is a technology that enables the existence of cryptocurrency. But you see, so we can actually look at blockchain and realize that it is really an alternative. It's a new way to organize data. Are you okay? It's a new way of organizing data. What blockchain? Okay. Blockchain. It's about data. If you look at it, it enables distributed public ledgers. What's a ledger? Ledger is what the banks use. If they want to pay you, the accountants use what we call a ledger. That whole, yes, exactly, ledger account and all that. Immutable data in a secure and encrypted way. So you can see that security and stuff are coming in. So it challenges your existing model. So hierarchical, if a flat file, hierarchical network database, relational database, then you are actually going, we don't know where we are going now. We have COVID now, isn't it? Okay, so that's not funny. But that is, the world keeps changing. So you have to just keep learning new things that come up. And so naturally, you see how it brings us to the next topic, which is probably the last but one or so, then I'm done. Database integrity. What's integrity? Integrity means we can trust the system. We can trust if someone has integrity. In fact, I attended Pempe College and our motto is character and integrity. So it means that you should be someone of, good reputation. People can trust you. You know what I'm saying? Integrity means that, oh, the thing is perfect. Are you okay? All right. So, but when we talk about database integrity, it's nothing different. What it means is that we can actually trust the database, that all the, what we call commits, yeah, in database, we call something commits. All the commits that we are making, like you make a transaction and you commit the transaction. Okay, you say, I want to withdraw 100 Ghana cedis. The database should be able to do due diligence, be faithful enough to keep that record for you. All right. If I say, the bank says they have taken you out of the system, truly, it shouldn't just go and take you out and leave your money in there. Are you okay? Maybe your money should give your money back to you, and then you can leave. I remember when Stanchart said I should come and, withdraw my money. I heard about how much. It was even embarrassing, like 100 Ghana cedis. They wrote a check for me. Then, because they said my business account doesn't have the minimum of 200,000, which I didn't have. I don't know if I've had 200,000 before, So database integrity is saying that the system should implement rules that allow you to actually trust it. So we have about 3 different types. We have what we call the entity integrity. Are you okay? The entity integrity rule says that every table that you have, make sure that you have a primary key. Then we have referential integrity, and that says that the referential integrity talks about a foreign key. So if you have a foreign key, there should be a matching primary key. There should be, or it should be null. There should be nothing in it. Are you okay? So referential integrity rule states that any foreign key value can only be in one or two states. Foreign key value refers to a primary key or null. Are you okay? So the two states are the foreign key referring to a primary key. Remember, I showed you that linkage between the customer table and then which one was that? Order table, remember?
The order table, yeah.
So that was a typical, enforcing the entity integrity. That means entity integrity is saying that make sure that there is a primary key for this table up here. Make sure this table too has a primary key, and And we have done that, haven't we? So there is entity integrity. Meanwhile, there seems to be a certain foreign key here. There should be a linkage between the foreign key. Are you okay? There should be a linkage between this one and that one. Okay? All right. So there we go. So we have what we call a domain integrity. So domain integrity, sorry, I'm going to go back.
So the referential says there should be a linkage.
Yes, it's saying that if you have a foreign key, then it should refer to a primary key.
Okay.
Or there should be nothing in it. Why is that? Because if someone said that they have there exists a table called your balance. Are you okay? In the bank. I mean, let me use the bank as an example. I don't want to use different examples, otherwise you get confused. So if in the bank there exists a balance for, who should I use? I want to make a reference. I want a name for Ajwa. Are you okay? Ajwa has a balance of what? So there's a table called balance, and in that table called balance, Ajwa has how much? 200 Ghana cedis in there. Meanwhile, there is no, when you go to another table of customer table, there is no Ajwa there. So who is owning that? So someone can chop that 200 Ghana cedis. So there will be no referential integrity. There will be no referential integrity in that case. So that is the idea of referential integrity. Domain integrity only refers to the fact that in every column, there should be values that we pull from. There should be a pool of values that we actually populate that column with. Are you okay? So domain is a set of values of the same type. In other words, if I want to keep something, let me go back to my Excel. You see that in this Excel here, okay, I said everything here, I want it to be what? Date. So I don't care how you go about it. Anything you put here should be date. That is domain. Are you okay? So if I put in R, really, it shouldn't allow me, but that is why Excel is not a database. A database will not allow you to put in R. At least Excel is able to convert the 3 to a date. So it's trying to keep some kind of domain integrity, but it's not working very well. So Excel is not a database. I worked for a company in which some of the staff, they were calling Excel database, and everybody was just saying, oh, my database, my database. Are you okay? But basically, Excel is not a database. It's not able to even do this domain integrity very well. But in the database, if you try to withdraw something and it's money, it has to be numbers. So the domains are pools of values from which actual values appearing in the column of the table are drawn. I hope it's a bit clear to you.
So say again, please.
So domain integrity is saying that we want to get or pull or get values of the same type in a particular column. So we can have a situation where we have said data in this column is actually date, okay? And yet we have something like rice here. This is a no-no. This is against what? Domain integrity. It's a no-no. It's not right. It means that we don't know what is happening in this column. We said that database is a collection of data, organized, yeah? Organized collection. So now, are we organized? I don't think we are organized. We are saying dates and we are having rice. So that is what, I mean, I hope you, do you understand it, Kakra?
Yes.
Okay, that's good. All right, so that is it for that. In fact, I will touch on this one. If you want to, the language that you use to query a database is called the structured query language. There are so many of them out there. Okay, well, a few of them that are good, but this one is the most popular. It's called the SQL or SQL. All right. So SQL allows you to simply query data. Okay. You just type it in. It's like when you're watching a movie, you see that they are actually typing, searching. Someone is searching for something. All the things that we do online, on Google, all those queries, behind it is a language which is actually converting your search. Are you okay? So we need to know that structured query language is very important. If you have the database, you have built a nice database, but how do we get the data? How does the police get to know, oh, are you a foreigner or you're not a foreigner? He holds a device, he types, and then there's a code, there's something, he types something, and then it goes and queries. So that one, whatever he typed in there, will now become will form a language. It's a language. Are you okay? It's just like having a translator in a court. You know, you can't speak English very well, so you get a translator. What we do on Google search, the Google search engine, the engine becomes like a translator. It translates everything that we are saying. Are you okay? So, structured query language is referred to, there is a computer language designed for managing data in a relational database. Okay? And originally based on relational algebra. In fact, I'm not talking about relational algebra and calculus, but in fact, it becomes, it gets interesting. How you query and all that belongs to what we call the field called relational algebra. But don't worry yourself about it. What is a database schema? Is a design. It's like the blueprint. Is that okay? Of how the data is to be structured. So the design, yeah. We don't say database design per se. The database schema. Are you okay? It's a structure described in the formal language supported by the database management system. So you have to get into the database. Are you okay? And then you start querying it. Is that okay? You have to get into the database and start querying. All right. Database maintenance, data modeling is just the way you build or design the database. Is that okay? So we are done with the integrity rules. We have database entity integrity, referential integrity, and we have domain integrity. All right. How many minutes do we have to end this? I thought this software would tell me so that I'll know when to end, but it seems it just keeps going and on and on and on, isn't it?
So my data.
The data is even getting finished. Okay, Prince. So this is it. This is it. In order to save time, I want you to read about database maintenance. Is that then I'll go to the next topic. Or you want me to talk about it? I don't know. It's up to you. But database modeling is about everything we just talked about. There are three things. You read about this one. Is that okay? Read about it. Read about it. Data modeling. In fact, three things you need to know: logical, conceptual, logical, and physical modeling. That is what it's all about. Is that okay? Okay. And then this drawing that you're seeing here is called the entity relationship diagram. So this is actually the entity. This is the relationship. This is another entity. These are the columns in the table. This is the table name. These are the columns. And then, yeah, we can relate one to the other. So there's a linkage. Are you okay? There's a foreign key here that links to You know, like, so you read about it and then ask me questions because of this situation. Yeah.
Yes, sir.
Are you good?
Yes, sir.
Okay. So if you don't have any question, can we end it here? Can we do the same thing again next week for the next topic?
Okay, sir.
Yeah. Okay.
Sir.
Take care. Stay safe and bye-bye.
Thank you, sir.
You're welcome.